Hello, welcome to our ME435 autonomous vehicles presentation. I'm Eddie Grill.
I'm Alex Pangrazi.
I'm Ben Johnston.
For Lab 1, we started by becoming familiar with the Jupyter Notebook interface. Afterwards, we learned about how to code the Jetbox kinematics by setting percentage speeds to the different motors. From there, we learned about adjusting the motor speeds and bias as the motor speeds change with our specific robot, and calculating inverse kinematics of the JetBot to get it to move to certain locations using certain wheel speeds. In Lab 2, we learned how to adjust the HSV values of camera mounted to the front of the JetBot to correct the color of the image it captures to better detect the yellow line in the center of our road maps. This would allow us to perform line following tasks so that the robot will move in a straight line at whatever wheel speeds we set. From there, we also developed a deep learning model to detect road signs such as a stop sign and a speed limit sign using the robot's camera and testing that model in real time to finish out that lab. In Lab 3, we learned how to connect the JetBot to the camera bot that's seen mounted to a bar that can be raised and lowered from the ceiling in the lab room. We also learned how to calibrate the camera bot because we are given a distorted image from the camera bot and using a matrix to correct the image that the camera bot produces. Using the camera bot, we could then read the April tag that's located on top of the JetBot. And using that April tag, we could determine the JetBot's location and therefore plan a path for the JetBot to move, as seen in our planned path from Lab 3 in the blue map in the image below. And from there, we had to design a controller to move the JetBot down the planned path.
All right, now we'll get into the flowchart, which gives an overall um, how the robot works. So it takes all of the inputs, puts them into some functions that are combined at a controller, which will control the robot to move. So now to get into the some of the some functions, the first one we want to talk about is the robot-to-robot communication, the April tag detection. So how this works is you'll get a image from the camera bot, and that image will be sent to the jet bot. And based on the calibration of it, it will give a current location and pose of the jet bot on the map. And that will be used for the path planning, which takes that same image from the camera bot and through image processing will create like a black and white image, which will only allow the path to be planned on the black roads. So it takes that current pose and a goal location and will generate paths and will calculate the shortest paths, which will be used and give you waypoints, which will be used for the PD controller. And the next subfunction is the sign recognition. It takes the image from the camera on the JetBot and using the trained deep learning model, it'll be able to detect what signs are right in front of it, and those signals will be used in the PD controller to tell it what to do. And the last subfunction that will be used in the PD controller is the path following. Uh, just like the sign detection, it takes the image from the JetBot. Also, the HSV values have to be tuned so that it picks up on the yellow line. And going with the line, it'll give you the linear and angular velocity. So all of the outputs that I just talked about, the current pose and position from the April tag, the sign detection, the angular and linear velocity from the path following, and the waypoints that you get from the path planning all go into the PD controller along with the proportional and derivative gain, which will help if anything, if there's noise in the system, we'll keep it like on track, along with the feedback that is the current pose and position of the robot. Um, all those go in there, and it will tell the robot what to do, like how the what speed the wheel should be at. So that goes into the basic robot controls and kinematics, which calculated by the wheel radius and the wheel base, and that outputs the wheel speed for the right and left wheel.
For our final project, and basically Lab 4, we decided to tackle 3 of the 5 learning objectives: kinematics and robot control, path planning, and then April tag and real-time location detection. To do this, our initial plan was to have the robot follow a assigned path to the house you can also see in frame, and then also, well, crash into it at some point eventually, which you can see there. Yeah, that was our assigned goal. That's what we wanted to do. So to do this, we got working. Our first step was to work on the path planning, which we did by using the camera bot, as mentioned before, using a binary map, assigning the values to determine what the rogues are. And when we were able to compute the path by selecting our initial and then final destination, we got this optimized path on the right. This would have worked, and as you can see, there are also all the other available paths that it could detect, but this was the shortest one. For the real-time location tracking, we basically just used the code from the lab session where we did the April tag testing for the first time, and we were able to pretty much port it over very easily using our tag number, which was 21, and it gave us relatively accurate real-time tracking, which was awesome, which was pretty cool. However, there were issues. As you can see, we were not able to get the kinematics to work, which we were assuming would be the easiest one. Unfortunately, it did not turn out that way. And this was a big thumbs down moment for us. So we were very worried about even passing our demo. However, we determined another solution to this, which was basically just have the robot move itself and then park, because we were still able to demonstrate the other methods and other learning objectives, and this helped us demonstrate our kinematic skills. And this was a big success. And the code for that is right here. Basically, it's very simple. It just uses the regular library that we did in Lab 1, and we just pre-programmed the path with some trial and error for just a couple minutes, and we were able to get it pretty consistent, albeit with the battery dying every now and then, but it did work. Anyways, thank you so much for watching our presentation. We greatly appreciate it and hope you have a great break.